In this video, we'll look through how the database optimizer decides which index to use, especially if there are multiple indexes. This is very useful if you want to know whether your table needs an extra index or not. Because if you have multiple indexes, how do you know which index the database is going to use? It's not going to use all of them all the time. It really depends. This video is going to explain these different kind of cases, right? This video is not going to discuss the combined indexes, one index that have multiple columns, right? Because I already discussed that. So let's say we have a beautiful table with just two columns, F1, F2. Column 1 has an index, F1 IDX, and column 2 has an index, F2 IDX. And we're going to do a select star from the table where F1 equal 1 and F2 equal 4. So let's go through some scenarios to see how the database optimizer decide to, should I use F1 index or F2 index? There are so many ways to solve this, to look for these values, right? So let's take a little case number 1. Case number 1 is when the database optimizer decides to use both of them. So what it does, it queries F1 IDX looking for the value 1 in this case, finding all the row IDs that matches and tuples in case of Postgres, row IDs in case of Oracle and SQL Server, and it collects all these row IDs. And then it does the same exact search but with the value 4 on F2 IDX. So it searches and collects a different set of row IDs, and in case of an AND, it will essentially do an intersection. It's like, okay, what is the values that are in here, not in here, and then essentially merges the results. And or it's gonna merge the result and essentially union them, right? So that's how it does it. The effective result set, the row IDs are collected. That's the final result. You go to the table, if necessary, obviously, and you collect the actual values from the table, from the heap, right? So when does it actually do this? It really depends. If the values are not too small, if we know that we're not going to get so little of a result, because if we're going to get a little of a result, it's not worth searching both indexes. One is enough, right? Especially in case of an AND, right? These cases gets really tedious, right? And if we get too large of a result, if we know that the index is going to turn so many rows, so many row IDs, it's just not worth looking through the index. In this case, we're going to go through the table index scan, right? So it really, really depends on, and that's all heuristics the database uses to decide what of this, right? So that's case 1. So let's talk about case 2. The case 2 is when the optimizer decides to use one index over the other. So let's take an example. We're going to show an example right here. The database decides to use F1 index only, search all the rows for the value of 1, and then we collect all the rows and then don't use the second index, right? Let's just go immediately to the table, fetch those rows, and then do a recondition, refilter the results based on F2 equal 4, right? So databases usually do that when they know that F2 index returns so many rows while F1 returns very few rows and the condition is an AND. Because if I know it's an AND, then I know, of course, I'm going to go with the smaller one, because anything that doesn't match F1, right, is out of the result set, right? So it's going to go with F1. Example is a primary key. If I have a primary key, the database almost always going to use the primary key index. In case of an AND, again, with an OR, it's a different situation, right? Because you get more results, right? And then go back to the table directly and fetch the results we want to, right? It's just not worth searching two indexes, because B trees are not cheap, guys. And even LSM trees are not cheap. Indexes are not cheap to search. Yeah, if you're searching, if you know that you're going to get so few of the values, then it's worth searching the index. If you know that you're going to get a lot of rows back, then it's not worth searching the index, and maybe table scan is actually better. And you might say, how do you know? How does the database know that, hey, this index is going to result so many rows versus this search is going to result into fewer rows? Well, there's something called the statistics. The stats, really powerful. The database keeps stats of the table, says, okay, here's the table, here's approximately how many rows there, here's approximately how many ones are there, here's approximately how many threes are there, and all these kind of values. So they are not 100% correct, but they give really a lot of values. And you can also always update these statistics with a command called analyze, or sometimes called, I think, gather statistics in Oracle, right? So that's the idea, okay? It really, again, depends on an and or an or here. But here's one example where we use one index over the other, right? Just one and then filter. So an index with a filter, that's case 2. And case number 3 is just the database decides, you know what? You guys suck. Both indexes suck. I'm not gonna... The search to get for the value f1 equal 1 and f2 equal 4 is just gonna return the whole table, almost the whole table, 3/4 of the table. I did my math and this is what I think. So guess what? I'm not gonna use both of you. I'm gonna already go to the index because I need to go there anyway, because I'm gonna select other columns. The database decides to search, the search will lead so many rows, just like let's go to the table directly, do filter because it's much cheaper. And some databases like Postgres does a threading, multi-threading, and issues so many workers, so you can do multiple workers to scan the table, right? So table statistics are very, very critical here. So if you got some wrong result, right? Let's say, here's where things get nasty. Sometimes, I got bit so many times with this. Here's an example. You bring a table, very fresh table, right? Empty, right? So there is statistics almost 0. It knows that, hey, table's empty. You insert 1 row, you insert 2 rows, 3 rows, and then the tables get updated every asynchronously, right? Now it knows it has only 3 rows. And then you do an operation to insert 3 million rows or 300 million rows. You just in bulk. And you're just immediately after you insert it, you just do queries. You know what will happen in this case? The database, if you don't update the statistics, you'll execute something like this and will say, hey, what should I do? Let's look at the statistic. Oh, this table has only 3 rows, so it's always easier to scan it fully. And in this case, it's going to do a full table scan, pulling all the 300 million rows to look through this. I've got bitten so many times by this because I forgot to update this, or immediately I did my queries after this. So always, if you're using Postgres, do analyze. What's the other command? Vacuum, full vacuum to clean up all that garbage, and then after that, just do an analyze. In Oracle, use gather schema statistics. In SQL Server, I forgot what's the correct execute planner. I forgot what it's called for the SQL Server. But yeah, you can do all this kind of stuff, guys, essentially. And for those who want to advance stuff, if you know what you're doing, if you really know what you're doing, you can use database hinting. You can, in the query, include some sort of a comments, like this one, the one you're seeing on the screen, to kind of force the database to say, hey, you database, you're dumb. You don't know anything. Please trust me. I want you to always use the index of F1 or use the index of F2 because I have more knowledge than you do because of certain situation, right? Because my application, I know what I just did. You are not caught up to what I just did as a database. So trust me, your stats are not up to date to what I'm about to do. Plus, maybe the human in this case are way smarter than machines, right? And unless the AI picks up anytime soon. I don't know. I don't think it will. But anytime soon, so it was gonna take time. All right, guys, that's it for me today. Very quick video talking about how these databases use the indexing. Very, very critical. Again, I omitted so many details, for example, so we'll give this we'll open up for questions, and we'll have some discussions on what if there is an or if there is a join. It completely changed the dynamic, right? The building a database is not something easy. It's really, really difficult. But these tools will help you while you're executing a query. At least you know, hey, I know that F1 is not going to have a lot of value. It's going to have, let's say, it's going to have a lot of values. Let's say you have 1, 2, 3. That's only the unique values you're going to have, right? Or, I don't know, let's take a real example. Let's say you're building a customer database, right? And you have the states, right? In the United States, like California, Texas, whatever, all of them, right? And let's say your database is almost exclusively all people from California, right? And you have an index on the state field. Obviously, if all of them are California, that's just a useless index right there. Because like what is gonna give me is if I search where state is equal to California, that's the entire table, right? So, but let's say you have 3 customers on Texas and 1 from Florida. Searching that Florida, is way faster than searching the 300 million, no, 300 million. That's the entire United States. But you get the idea, right? If you have one value or few values, indexes are beautiful for this, right? But if you have so much rows that you're coming back, that's where you play the game of multiple indexes. Okay, you know what? I know that this index is going to give me this much rows back. I'm going to slash it down with another index. So let's put that. But you have to think of how sparse your table looks like, right? And in these kind of cases. All right, I'm going to leave you there, guys. I'm going to see you in the next one. You guys stay awesome. Goodbye.